The zero product property is what we're going to use to solve quadratic equations using the factoring method. What does that mean? That means if I'm multiplying two things together and their product is zero, either A is zero or B is zero or both. Now when we solve a quadratic equation that has 2 as the highest exponent, x squared, how many solutions should it have? How many factors did it have? 2, okay? So whereas when we were in chapter 3 and we were solving all those little linear equations, how many answers did we get every time? We got 1, right? So now we're solving the quadratic equation. It should have 2 solutions. Now some of them are called a double root or a double solution, and we'll talk about that. But most quadratic equations will have 2 solutions. All right, thinking along that line, let's say that I had a cubic equation whose highest exponent was 3. How many solutions do you think they have? 3. If I had a quartic equation that had the highest exponent is 4, how many solutions do you think it has? Could have up to 4, all right? So the highest exponent is telling you how many solutions that equation has. Now this problem is pre-factored. That was nice of them. Already been factored using trial and error. When I am solving a quadratic equation, I am trying to find, like in those graphs I was showing you earlier, I'm trying to find the x-intercepts. What are the most important points on a graph? The x and y intercepts, okay? So if I'm trying to find the x-intercepts, what is y on a point on the x-axis? It's 0. So here's my y. I'm plugging in 0 there. And at some point in the equation, that's what you're going to do. Now you're going to have to factor all of yours. This one's already factored for us. So to find an x-intercept, plug in 0 for y. All right, now thinking about the zero product property. This is a factor. This is a factor. If I multiply those together, I'm getting 0. What did that zero product property say? Well, if these are multiplied together to give me 0, either this factor is equal to 0, or this factor is equal to 0, or both. That's where my 2 solutions are going to come from. I'm going to take all my factors, listen to this part, I'm going to take all my factors which contain variables, and set them equal to 0. What kind of factor didn't contain a variable? The only kind that could be is if we factored out a greatest common factor that just had a number, like factored out a 9 or something, in one of the problems I think we worked yesterday. So any factor that contains a variable, you're just going to set it equal to 0. Now I'm pretty sure that most 5th graders could solve this problem, right? What would you do to both sides? Subtract 2. What would you do to this problem? Add 3. You can do that in your head. There's my 2 solutions. If I were graphing, this is a parabola, this is -2, this is +3. That graph would, do something like this. I'm not graphing it exactly, but there would be its 2 x-intercepts, and that's what we're finding. I'll show you how to find the y-intercept in just a few minutes. It's very easy. All right, this is a quadratic trinomial. A quadratic trinomial's got an x squared, it's got 3 terms. And I'm looking to find its x-intercept. So I'm going to plug in 0 for y. This one has not been pre-factored. We have to do that. All right, the first rule of factoring is to factor out the greatest common factor. Does this have one? No. Is this a perfect square trinomial? 28. That's not a perfect square, is it? Okay. So what do I have to try? Did I need to do bottoms up? This is a 1 right up here. Trial and error. Okay. So I need an x here and an x here. What does this positive tell me? I've got like signs, same signs. They're both negative. All right, now I need factors of 28 that I would add to give me 11. 7 and 4. So the zero product property says that if this times this is 0, that either this is 0 or this is 0 or both. And so we have to find 2 solutions. We set them equal to 0. Over here we add 7 over here we add 4, and there's our 2 x-intercepts.
What would you do if it was like a 3 in front of the x or something?
If 3 for the x squared, we could do bottoms up or we could do trial and error. Good question. Okay, now, I told you I was also going to talk about the other part of the graph, the y-intercept. Think about a point that's on the y-axis. What's x? 0. Okay. So think about that. What if I plug in 0 where all the x's are? What would y equal? 28. So you can do that in your head, right? This would have a huge y-intercept up at 28, but it would cross the x-axis at 7 and at 4. So it'd be kind of skinny. Can you imagine just at 4 and at 7 on the graph, but crossing the y-axis way, way up at 28. So that's what that parabola would look like, just to give you an idea. All right, this one's been pre-factored. Yes, sir. A parabola can turn upside down, and we'll talk about this more in Algebra 2, when the x squared is negative. Do you guys remember talking about translations, dilations, and reflections at some point? All right, that happens. The reflection happens. The flip of it, when it turns it upside down, happens when the x squared in the problem is negative. And it's not been in any of these we've done yet. But all right, so this one's been pre-factored. I'm looking for the x-intercept, so I plug in 0 for y. All right, you find the 2 x-intercepts. Okay, what are our 2 solutions? What's the solution here?
6.
Good. And here?
-5.
So we did all that factoring. We had to do it before we could do this today, but then this is it. We're just going to take our factors, set them equal to 0. So this should be the easy part, if we can remember all that factoring. All right, factor this one. We're going to plug in 0 for y. Why do I keep plugging in 0 for y? What am I looking for? X-intercepts. Okay. So you guys are going to factor. There's not a greatest common factor here. This is not a perfect square trinomial. So do it with trial and error.
I feel like I aced that test, but every time I feel like an ace test,
It's not
I get
good.
like a 75 or something like that.
I remember doing that too. That was more me in geometry than algebra.
No, I hate when you're studying for a test and like before the test is handed out, like you know it and you're like, yeah, I got this, and then when you get the test, it just
You like forget everything.
That's me.
Yes.
That's me all the time.
that happened all the time in Miss Blackman's. It was like,
Oh, this one, these tests are easy.
oh, so where'd it go?
I like Miss Black.
That's how you get it.
All right, you guys agree? That's very good. Very good. This isn't so bad, right?
No.
If we can just get this part, get the factoring part, we'll be good. All right. This is very important. I've said it once before, but let me say it again. When the greatest common factor contains a variable, set it equal to 0 also. Any factor that contains a variable, whether it's greatest common factor or trial and error, whatever it is, any factor that contains a variable, set it equal to 0. That's important to remember. All right, this is 2 terms. With 2 terms, we can do greatest common factor, and we've also learned dots with the difference of 2 squares, okay? So what would you say is the greatest common factor? It's not 4, it's not 8,
16.
it's 16. All right, would you factor out, and this is personal preference, would you factor out a positive 16 or negative 16?
Negative.
The leading coefficient's negative. Typically, we would factor out a negative. All right, so if we factor out a negative 16, what?
X.
There's also a common x, and the smallest exponent is 1. So I'm going to factor out a negative 16x. What will I get here? Positive x, and here? You guys got the calculator, right?
6.
And -6. Right, there's my two factors. They both contain variables. This one's a monomial, and this one's a binomial. Doesn't matter. If they have variables in them, you set it equal to 0. So I set this equal to 0, and this equal to 0, and solve for x. Alright, I'm going to divide both sides by -16, and x is 0. That's not too hard. Over here, add 6. X is 6. By the way, how could I know without a shadow of a doubt that was right? You can do what? Well, that's true. On this one, anything divided by 0 divided by anything 0. But how could I know, and no matter what my problem is, that my two solutions work? Can I plug them in? Like if I plugged in 0 here, squared it, multiplied it by -16, multiplied 0 here, multiplied by 96, added them, I'd obviously get 0, right? What about if I plugged in 6 here and here in my calculator? What would I get when I type that in? 0. So that way I know I've got the right answer, okay? Alright, you guys do this one. It's a binomial. Factor at a greatest common factor, and then if we had dots, we would do it. But I think this was just got a greatest common factor. Alright, divide both sides by -10x. That's our greatest common factor. Why is this negative right here? It's an easy question. Why is this negative? Because I got what? No, that's all I heard. So why is this negative? Because I've got different signs. Okay, so divide both sides by -10, get 0. Add 10 to both sides here and get 10. Alright. Now we're just going to practice. This is a quadratic trinomial. Is it have a greatest common factor?
No.
Is it a perfect square trinomial?
No.
Alright, so what will we have to do?
Trial and error.
Trial and error. Alright, so factor with trial and error. Alright, here you go. That's it. Is this easy?
Yes.
So once we got factor, we can do this now. Alright, now, you either have to do trial and error or bottoms up. Alright, here's a good question. We're used to doing bottoms up, we multiply by the last number. This is an equation now, but you multiply it by the 5, which is the constant term in the quadratic trinomial.
And when I was little, I had good time to go see places.
Yeah.
Like in the ditch.
In the dryer.
Oh yeah, dry.
Alright, he did this one with a bottoms up multiplied by 4, got a -20, factor with a +5 and -4. Remember this part divided by 4, this one reduced. This one he did bottoms up and got 4x plus 5. And then I think the most problem that anybody had was remembering how to do this two-step equation. Subtract 5 and then divide by this 4. So you get -1 1/4, -5 fourths, -1.25. And on this side, just added 1. That's it. Alright, try these two.
Yeah, I don't think you did that right.
Alright, let's look at this one. This one's nicer. Alright, +8, -2 give you a +6. You set them equal to 0, got -8 and +2. Very good. Alright, he did this with a trial and error, and he has 2x minus 1 and x plus 3 because 6 minus 1 is 5. He set 2x minus 1 equal to 0, added 1 to both sides, got 2x equal 1 divided by 2, so x is 1/2. X plus 3 equals 0, x is -3. Those are correct. Does anybody have a question? Yes, sir. Alright, if we do the same problem with bottoms up, we multiply here. we factor, we come back and divide by 2. This one reduces. This one is bottoms up. We get the same factors as up there, okay? We set these equal to 0. And this one, set it equal to 0. We're gonna add 1 to both sides and then divide by 2. So bottoms up or trial and error gets the same thing.
I did, in the
Yeah, a lot of
parentheses-
people are leaving it like, right, you know, to this point right here.
In the parentheses, I
I
got,
always forget the 2.
3 and 2,
Yeah. Can you fix it?
yeah.
Alright, on page 468, let's look at 8 through 14. Alright, looking at number 8, he set 0 in for y. The factors were x plus 7 and x minus 6, so x is negative 7 and x is 6. Alright, number 9.
Yeah. It's crazy.
Somebody else do that one.
Well, at least we got the answer out. It's the same on number 9. Yeah.
You can slide it back up.
Yeah.
Just be quiet, please. Hey girls, let's be quiet, please. Alright, he factored out a 5x. If you factor out a negative 5x and got positive 5x minus 1, you're in the same boat he's in. He said his factors equal to 0 and got 0 and 1/5. Do you guys agree?
Yes.
Alright, next is number 10. Yeah, 0.2, 1/5. Alright, do y'all agree with 0 and 1/4 for 0.25? Let's see, there it is. She factored out just a 3x. Remember, anything divided by itself is 1, in case you messed that one up there, because it wouldn't be uncommon to do that. Alright, number 11. While he's working this, by the way, if you've done number 12, let me call the answers out. They are -2 and -5. 13, +2 and +5. And 14, the answers are 2 and -2.5 or -5/2, -2.5.
Or on 12 and 13, they're the same equations, but the one was probably
They're right, just different sizes. Alright, on number 11, he factored out a negative 15x, left you with x minus 2, so the answers are 0 and 2. Alright, so I think we understand a little bit more about why did we ever factor to begin with, so that we could graph something other than a linear equation. We can graph curves, and the bigger the polynomials get, the bigger the exponents get, the more factoring we have to do, and just kind of deeper and deeper. But this is why we learn how to factor. Alright, your assignment is page 468. We're going to do 15 to 35. You have about 5 minutes to work on that in class, and what you don't finish, you do homework.